Hey guys, so this is Riz to help you out on the fourth part of the 3.4 notes here. Actually, we're pretty much done with the notes. We're just going to go over the homework together to make sure you guys can understand the conceptual ideas behind this second derivative. All right, so when we're looking at a graph here, in these first problem, they want us to graph the first derivative and the second derivative here. So the first derivative here is, remember, we look to see where does the graph change direction here. And so this graph changes direction right here about 1. So we're going to micropoint on our x-axis at 1. Now the direction of the graph, it's going down and then switches to going up. So we need to be below the x-axis and to above the x-axis. And so there is the first derivative. Now the second derivative is the derivative of the derivative. So if we got a straight flat line here, this graph doesn't change direction at all. It's constantly going up. So we just have to put a constant flat slope here. And that flat slope would be, I don't know, maybe 2. So we'll put a line here and we'll label this one f double prime, which makes sense. Okay, this is a parabola, that's x squared. The derivative of an x squared would be some x to the first power. And so the derivative of some x to the first power is just some constant number. Okay, let's look at this one here. So where does the graph change direction? The graph changes direction, I would say probably right here just before the x-axis, and then probably right here about at 1.5 in between 1 and 2. So the graph is going up, then it's going down, and then it's going up. So the graph needs to be above the x-axis, below the x-axis, and then back above. So above, below, above. All right, that's the first derivative. Now, what's the derivative of the first derivative? We see, okay, where does this derivative change direction? I'd probably say somewhere around here, it changes direction. The graph is going down, and then it's going up. So it needs to be below, then above. Now the point here is we can look at the original problem and see, okay, right here on the original graph would probably be the point where it switches from concave down to concave up. And that's right where we have our same point where the second derivative crosses the x-axis. Okay, not too bad. Okay, next couple problems here, we're going to read through these and we're going to try to sketch the graph. Okay, so we got some information here and we've got to try to figure out, okay, what's going on with this graph? What does it look like? All right, so I'm going to go through and just kind of make a random graph here. What we know, okay, we know that f of 2 equals f of 4 equals 0. So if we think about it, that means we have a point at 2, 0. We also have another point at 4, 0. So those are basically our x-intercepts. So I'm going to put those 1, 2, 3, 4. Okay, so I'm going to make sure we put those dots on our graph. All right, it says f prime of x is less than 0 for any x less than 3. Okay, so maybe we have kind of like a first derivative line here. First derivative. So anything less than 0, any less x is less than 3. So 3 is a critical point. It's less than 0, so the graph is going down. It doesn't exist at 3. So I'm going to put like an x here to make sure that it's not going to be like a minimum. It's not going to be a maximum. It's going to be a point that we don't know. You know, usually those are like extremely sharp curves. And then x prime is greater than 0, so it's positive for any x greater than 3. So the graph needs to be going down, and then it switches to going up at 3. And and it does not exist. The other thing is the second derivative, x is less than 3 for any x not equal to 3. So we still have our point 3 here, so that means it's curved down and curved down. So this graph needs to be going down and curved down until we get to the point 3, and it also needs to go through this graph, this point here. So going down, curved down, and then after 3, it needs to be going up, curved up, and still go through this point here. So maybe it's curved down, but it's going up. Okay, and if you remember here, like when we have these steep points, like if it curved nicely, that would be a minimum, but that would make a sharp point, so it doesn't exist here. All right, let's try the next one here. Okay, kind of the same thing going on here. All right, we got a critical point at 0, 0, or not an x-intercept at 0, 0, and another one at 2. All right, it says first derivative, I'm going to make a line here, that f prime of x is greater than 0 for any x less than 1. So, okay, we got 1 on here, and it's going up, positive, greater than 0 is positive. It equals 0, so that would be a min or a max. Let's see, and then it goes down, right, less than 0. Okay, so this would be curved like this. So we got a max at 1. The other thing that we know here is that f double prime of x, it just says is greater than 0. So it's constantly curved, or less than 0. It's constantly curved down. Okay, so if we think about it here and we kind of labeled it, what's going on here? We got a graph going up and then going down, switching at 1. That would be some maximum point there, and the graph just needs to go up, go down. Okay. All right, so I'm going to let these guys, let you look at these examples here. These two examples should really help you out with problem 55 and 56. You can see that these are very similar problems. You can see 53 compared to 55. It starts out the same. All right, except for this sign is switched here. This sign is switched there. So think about how the graph would change if you changed those two signs. How does the direction of the graph change? Same thing with 56 here, very similar to 54, but how's that going to change? You can check your answers on the answer key online. If not, this pretty much wraps up part 4. What you guys will do next is the 3.4 homework quiz. Just like any other homework quiz here, guys, there are no video notes, but you guys can use any reference. You guys can work together on the homework quiz, and I will see you guys next time for that. Have a great day, and let's get ready for 3.5. See you later.